This is the tutorial for GCF, a greatest common factor. And a factor, before we get into how to find greatest common factor, let's look at what a factor is. A factor, or divisor is sometimes what it's called, is a number that builds another number that you could divide evenly into a number. So let's use 28 as an example. All of the factors of 28 are the numbers you could multiply together to build it, or numbers that divide evenly into 28. 1 times 28 builds 28. 2 times 14 builds it. 4 times 7 builds 28. So all of these are factors of 28, and they would divide evenly. 2 goes into 28 evenly, 4 goes into 28 evenly, 7 times. 14 goes into 28 evenly, 2 times. So they are divisors that go in evenly to 28. So sometimes you'll hear it called greatest common factor, because these are the factors to build this number, and sometimes people will call it greatest common divisor, because these are divisors that go evenly into 28. When we talk about a greatest common factor, what we're doing is comparing two or more numbers, looking at the factors that build them, and finding which of those factors is the match that is the largest. So if I looked at the number 24 and broke down his factors, 1 times 24 builds 24, 2 times 12 does it, 3 times 8 does, and 4 times 6 does, and that's about it. If I wanted to know what the greatest common factor, the factor that they share, these two numbers share that are the largest, I would look at all their factors, 1, 2, 4, 7, 14, 28, and this 24's factors 1, 2, 3, 4, 6, 8, 12, 24, and I would find which of them were matches. A 1, of course, is a match. It's going to be a match for every number, so we don't really worry about that one. 2 is a match. 4 is a match. 3 is not. 7 is not. 6 is not. 8 is not. 12 is not. 24 is not. 14 is not. And 28 is not. Of these matches, we want to know which one is greatest, the biggest. Well, of these matches, 4 is the biggest. So the greatest common divisor, or greatest common factor that these two numbers share, is 4. So remember that these are the divisors that divide evenly into both of these numbers, and the largest one that does that, that they match up with, is the number they share. Well, if we start dividing the same numbers into the numbers that will go into both of them, then we can very quickly find which ones are the matches. So let me show you what I mean. So what I'm going to do is do some upside down division, because I want to be able to continue dividing afterwards. So I'm doing like an upside down division, but I'm going to extend this out a little bit for my divisor to sit on there. And I'm going to ask myself what number divides evenly into both of them. Well, you've practiced this a little bit already, so you're probably starting to recognize these are both even numbers. So I'll put 2 into there. And 2 will fit into 28 14 times, and 2 will fit into 24 12 times. And then I'm going to check again, is there a number that can divide into both of those? And I do notice again that's an even number and that's an even number, so yes, 2 will go into both of them again. 2 will fit into 14 7 times, and 2 will fit into 12 6 times. And then I check again, is there a number that fits into both of these? Well, 6 is even, so 2 will go into it, but 7 is not. 7 is actually prime, and 7 doesn't fit into 6, so I really am stuck. And as soon as you're stuck, then for GCF, when you are looking for GCF, imagine him being the grumpy guy. He does not like numbers that he cannot see around the corner. He only likes the numbers that he can see on this side of the wall. So you multiply all of the numbers on the side together. So here I have 2 times 2, because that is all of the shared divisors that will go into both of those numbers. And if you multiply all of its shared divisors together, it's going to create your greatest common divisor. And that was our we do. I'm sorry, I should have told you ahead of time. Make sure you get that copied down. Okay, and now it's time for the you do. Now you do not have to write down this whole section, but I just wanted to present it to you in the way that you would utilize this skill. So this is a GCF type of a question, a something that you would use the GCF tool for. So if you're faced with things, it's several things that you want to make into fair groupings and have none left over, GCF is the tool you want to use. So I have 36 Hershey Kisses and 42 Caramel Bites. I want to make fair groupings of candies with none left over. How many groups can I make? How many kisses will be in each group? And how many caramels will be in each group? So this is a GCF type of question. So go ahead and push pause and see if you can figure out the answers to each of these three questions. Go ahead. Okay, so now you have hopefully gotten to an answer, or gotten as far as you can, and let's see how you did. Again, this type of question, when you're grouping things into fair groupings and you don't want to have any left over, you want to make sure it's all nice and fair, you would use the GCF tool. So we're going to use our upside down division, our magic ladder. And we're just taking the factors that they share and dividing those factors into both numbers at the same time. It's kind of a little bit of a shortcut. So a number that goes into both of these numbers evenly, I notice they're both even, so it would be 2. There's other numbers, but 2 is the one I noticed right away. I'm not sure exactly how many times 2 goes into 36 evenly, but that's okay. It's easy enough to figure out with this little shortcut. 2 is into 3 once, that's fast. With 1 left over, bring down the 6. 2 is into 16 8 times, so that was pretty quick to figure out. Same with 2 into 42, I'm not positive, but I can do the shortcut to find out, and it just takes me a second. 2 is into 4 twice, with 0 left over, and 2 is into 2 once, 21. Then I'm going to check again, and it's really important that I get to the lowest point so that until I'm stuck. And when I look at these numbers, I can tell I'm not stuck because I know that 18 is a multiple of 3. 3 goes into 18 evenly, and I also know that 3 goes into 21 evenly. So I'm going to divide 3 in. 3 is into 18 6 times, and 3 is into 21 7 times. And so now I just double check and make sure if I'm stuck or not. And 6 is even, so 2 goes into that, but not into 7. 7 is prime, doesn't go into 6. And usually anytime you have one number that's just one away from another number, you're kind of stuck. So I am stuck. And remember, GCF is the grumpy guy. Grrr. He does not like numbers he cannot see, the numbers that are around the corner here. He only likes numbers that he can see on this side of the wall. So he's going to multiply just the numbers on the side, and that is just 2 times 3 equals 6. And what this tells us is that given candies of 36 and 42, and if I want it to be fair with none left over, because people will fight over the leftover ones, this tells me I can make 6 fair groupings. The GCF is 6, so I can make 6 piles of candies. 36 was the Hershey Kisses, and 42 was the caramels. So how many kisses in each group? Well, I looked down the 36 row, and what I ended at is 6. So each group is going to have 6 kisses, and then each group is going to have 7 caramels. And it'll be fair groups. Everybody will get 6 Hershey Kisses and 7 caramels, so nobody will be fighting with each other. So that is the answer to this one. This is GCF, and this is the type of thing you use it for. Hopefully that clarifies this a bit. You have 3 practice problems on your tutorial sheet, so go ahead and give those a try.